So the gradient here is what? Together, gradient? 0. He's okay. Gradient here? Oops, hang on.
1.
Gradient of 1, correct. This one here?
-1.
That one here?
1.
And this one here? -1. He's going downhill. This one here, we've got a run of 2 and a rise of 1. So the rise is the change in y, and the run is the change in x. And gradient is rise divided by run. So this is a gradient of a half, but he's going downhill, so it's actually -1/2. Negative 1/3. Negative negative 1/5. What about this one? A fifth? A quarter? A third? A half? 1, 2, 3. What's that? -3? -5. How about that? Negative. Hang on. Rise over run. 3 upon 2, so it's 1.5. So -1.5. Okay. So the rise is 3, the run is 2. Rise divided by run, 3 divided by 2 is actually 1.5. Does that make sense? And it's negative because he's going downhill. If I changed it to this way, where I had a rise of 3 and a run of 2, it's positive 1.5, because if I went across 1, I'd go up 1.5. In fact, that's a good way of looking at it, that you can always sort of check your calculations by saying your gradient is really for every 1 change in x, so for every 1 this way, what happens to y? So it went 1.5 up. 1.5 up. But we use these 2 points because we can see them better, because they're actually in a nice spot. So if you were asked, draw a gradient of 4, you'd start here, go 1 across, and you go 1, 2, 3, 4, and that would be your gradient. Does that make sense? Draw a gradient of 1. You'd start here, go across 1, go up 1. Draw a gradient of a half. Start here, go across 1, go up a half. But it's sort of easier to maybe look at go across 2 and up 1. Same difference. Does that make sense? Yeah. So in that thing, if you say draw a gradient of 3, you're just thinking, okay, I've got to go across 1, I've got to go up 3. So you've got to draw that. Badly done. It's probably better to have a line and draw it like that. So what's this gradient here? 1. That. 4. A half, a third, a quarter, a fifth. Make sense? Okay, so we've got a gradient here of 0. Is that okay? Yeah. If I go across 1 and up 1, I've got a gradient of 1. Now, I'm just going to trace that and say if I move this line around, all those lines have got a gradient of 1. Does that make sense? Let me do that again this way. Y equals x. Y equals x minus 1. Y equals x minus 3. Y equals, y equals x plus 3, y equals x plus 2, y equals x plus 1. All of those have gradients of 1. Okay? I don't want to trace that anymore. So they've all got a gradient of 1. Does that make sense?
Yeah.
So gradient is slope. So it doesn't matter where I put the skiing man, they've all got the gradient of 1. Now I'm going to change his gradient. I'm going to make it negative 1. So now if I went y equals negative x, do you see that one appear? Y equals negative x plus 1. See that one appear? Y equals negative x plus 2. Y equals negative x plus 3. So those ones have all got the gradient of negative 1, because they're all going downhill, and it's all, 1, 1. Does that make sense? They're all different y-intercepts, so they're in different spots, but the gradient is the same. Okay? Now let's have a look at a gradient of a half, for example. It doesn't matter if you think of it this way or if you think of it that way, it's still the same slope. Does that make sense? So we look at the rise, which is our change in y, over our run, which is our change in x. Okay? So 1 divided by 2 is a half. So that's the gradient of a half. So if I go y equals 0.5x, I get that line appearing. Does that make sense? Y equals 0.5x plus 2, I get that, whoops, point x, 0.5x plus 2. Make sense? Yes? So that line here and that line here have the gradient of a half. There's a nod. Good. Now I'm going to just go into here and have a look at all of those lines. And I really would quite like to get rid of a lot of them. So let's see. I'm actually just making them invisible. Okay. So what I want to do now is make this gradient 3. Something like that. So I better put it in the right spot. Come here. There. And I want to have... There we go. Almost. Right. That's okay? Gradient of 3? Can you give me the equation of a line that has the gradient of 3 and goes through the origin, the point 0, 0? Y equals? What's the gradient? 3x. So that made it go through the origin, and it's got a gradient of 3. Give me an equation of a line that's the same slope but goes through the 1. Can we see the pattern? Can you give me a line with the same slope of 3 but going through 2? Y equals 3x plus 2. Okay, can you give me a line of the same slope, 3, but goes through 4? Y equals 3x plus... Hamase, can you give me an equation with the same slope of 3, but going through this point here, negative 1. 0, negative 1. Minus 1. Yeah. Making sense? Yeah. Now can you give me ones with the slope this way, but going through the 4? So we're going to have a negative, what's this gradient? Negative 3. So we're going to go y equals negative 3 oh, where did that happen? Y equals negative 3x plus 4. There we go. y equals negative 3x plus, I want it going through here, plus 2. Okay. Y equals negative 3x plus, I want it, 1. I want it going through there. Okay, I want it going through the origin. So y equals
Negative 3 plus 0.
x plus, oh, plus 0, yeah. Negative 3x.
Oh, I get it now.
Get it now? Yeah. So all of those have that same slope, but they have different y-intercepts. Okay?